In section 3.1, we're discussing pairs of lines and angles. We're talking about types of lines and angle pairs. So first thing is we're going to talk about two different kinds of lines that do not intersect. Remember that the word intersect means cross or meet. Now you're very familiar with this type of lines that do not intersect or do not cross as parallel lines. There's also another type of lines that do not intersect, and they're called skew lines. The difference here, when we think of parallel lines, of course they don't intersect, they don't cross, but they are coplanar, meaning they're in the same plane, so that same flat surface. Whereas skew lines also do not cross, they don't intersect, but they're not coplanar. They're not on the same plane, meaning you could not do a flat surface through both of those lines. And I'll talk a little more about skew lines in a second here. But parallel lines, we need some more basics. If these lines were parallel, there is a mark that I can put on here. Now we know congruent line segments, we did tick marks. To mark lines parallel and indicate that these lines will never cross, you do the same number of arrows in the same direction. So now I've indicated that these lines are parallel because they each have an arrow on them. You can fill in the arrow or leave it open like that, so I could like fill in this arrow. And you might see it done either way, either just kind of that open arrow or filled in. And if there were another pair of parallel lines that I needed to indicate, then I would have a second arrow on both of those. Okay, so same number of arrows means they're parallel. And also there's a symbol to say that two lines are parallel. Let's say that this is line M and this is line K, and I wanted to say M and K are parallel. I literally draw two parallel lines in between and say M is parallel to K, and now I know that those lines are parallel because of that symbol of two mini parallel lines, basically. Now, what's the difference between parallel lines and skew lines? Remember that skew lines are not in the same plane. Like in the room you're sitting in right now, let's say you want an example of parallel lines, and you look up at the above you pretty much where the ceiling hits that front wall, and you look at that line across the top of the room. And then you look at the bottom of the room in front of you where the floor meets that front wall. Now those are parallel lines because both of those lines are along the top and bottom of the wall in front of you. But skew lines are not on the same wall, for instance. They're not in the same plane. They're not coplanar. Look to sort of to your left where the wall in front of you meets the wall to the side of you, and look at that vertical line, okay, where the wall in front of you meets the side wall. Now think about that line, and then look over to your right where the floor you're sitting on meets the right wall, the wall to the right of you. And there's a line that goes along the base of the floor where you're sitting that hits that right wall. Now those two lines that we identified, the one to your left that's going vertical up and down, and the one horizontal along the floor, those are skew. If you extended those lines forever, they would never cross. So they are not intersecting. But they're not in the same plane because there's not one wall or one surface that could go through those. So those are an example of skew lines. They don't cross, but they're not in the same plane or on the same wall. And finally, another parallel item, parallel planes. We know parallel means that things don't cross. Parallel planes, remember planes are flat surfaces, are two planes that do not intersect. And you should be able to come up with a good example right in the room you're sitting in. Two planes that don't intersect. Can you identify two planes that don't intersect? Well, how about the floor and the ceiling? Okay, those are parallel planes. Or how about the wall to your left and to your right, or in front of you and behind you? Okay, those are parallel planes, flat surfaces that never intersect. We've already discussed perpendicular, so let's look at an example in basically sort of a room shape. Think about the room always when you're doing these examples, it kind of helps. But I'm looking at a rectangular prism, sort of a box shape here, and I have all of these lines or line segments, and I want to come up with some specific examples using the terms we know. So let's come up with lines that are perpendicular to line EH. What does perpendicular mean again? Perpendicular means meets at a right angle. I'm trying to go at a right angle to line EH, so I'm just highlighting EH in green here. Now perpendicular means intersects at a right angle. And think about all the lines that intersect EH at a right angle. So I'm looking at point E, and I notice that this line would intersect at a right angle. Now this is line EF. You notice they're doing line symbols over the top because we're imagining this going on forever. Actually, at E, isn't there another line that would meet at a right angle? If we picture this in 3D, wouldn't this line meet at a right angle? Because that'd be like the floor meeting the front wall's baseboard. And that line is ED, or DE. And I look at EH again, I say, well, what about intersections at H that are perpendicular at a right angle? How about this line here, GH? And finally, at H, there's one more line that is perpendicular, meets at a right angle, and that would be line CH. And make sure you have your line symbol over all those. Okay. Next example, we're using that word skew. Remember that skew lines do not cross, but they cannot be on the same plane. They cannot be on the same flat surface. So I'm going skew to line GH. Where is that? GH would be here, containing point A. So I have to find lines that go through point A that are skew to this line, meaning they will not cross it, but they're not parallel. They're not in the same plane. Well, what about AF? Picture this line going on forever and this line going on forever. They won't ever cross, but they're not on the same flat surface, so they are skew. Line AF is my first example. What about this line AD? Actually, this line would be parallel to this line because you could picture a wall, a flat surface, a plane going through that would contain AD and GH. I know it's not actually here in the box, but you could picture that plane slicing through. So this would technically be parallel, so I'm not going to name that. But what about the last line through A, which is AB? Now, if this line continues even forever, and this line continues forever, they will never cross, but they're not on the same plane. So line AB is skew to line GH. Now there are other lines skew to line GH, it just said that they had to contain point A. If I wanted to come up with some other skew lines, DC would be skew, it just doesn't have point A. That would go on forever, never hit this GH. EH is at a right angle, this is at a right angle, this is parallel, at a right angle, at a right angle. Parallel, parallel. What about this line here? Also skew. This would go on forever, this would go on forever, never intersect. So those would be the additional ones we'd name if we didn't have the restriction of containing point A. Alright, what do we have next here? List the lines parallel to line DC. Line DC is here, and I want to list everything parallel, meaning they don't intersect, but they have to be in the same plane. What about EH right back here? Definitely parallel. And on the same plane because they're both on this bottom plane. So line EH is parallel to DC. What about right up here? These two, this line with DC is on this front surface, and that would be line AB. Parallel, will never intersect. And there is one more. Remember how AD was actually parallel to GH because you picture this plane going through the middle? Picture a plane going kind of diagonal, tilting back through DC and FG. This would also be parallel because you could picture that plane slicing through. So line FG, also parallel. And finally, identify planes parallel to plane AFE. Remember, you name a plane with 3 letters here. So I need a plane, a flat surface, parallel to this plane AFE. Now I know if I'm going to name a plane, I better do 3 letters as well. Which plane is AFE? Let's see. A is here, F is here, E is here. These 3 points are on this plane on the left-hand side. The plane that would be parallel to that one or never intersect it would be over here. This plane, I can name any 3 letters. It could be B or C or H or G, any combination of 3 letters. I'm just going to do B, H, G. I don't know. Could be any combo of 3 letters there. So working with our terms, parallel, perpendicular, and skew. Alright, 2 more postulates here. Parallel postulate and perpendicular postulate. What these say is they're kind of the same idea, just substitute the word parallel or perpendicular. But there's exactly one line that is parallel, or exactly one line that is perpendicular to a line from a point not on the line. I have this point, I have this random line. There's only one line that I could draw that would be parallel to this line that goes through this line. And if I wanted to draw that line. I have to go through that and be parallel. I'll change the color of this here to indicate that it's a new one. But this would be the only line that I could do through that point that would be parallel to that line. Anything here would be parallel. This is the only parallel line that goes through that point. Remember, to indicate parallel, you do the same number of arrows. So now I have proved that those are parallel. And perpendicular postulate says there's exactly one line that would be perpendicular to this line from this point not on the line. So I'll grab my line tool again. I have to go perpendicular, meaning intersect at a right angle, to this line through that point, and I'll change the color here. Now, again, anything here would be perpendicular, but if it has to go through that point, this is the only spot. Anything at an angle would not count. Again, so perpendicular through that point, that's the only line that you can draw that would fit those conditions. If I want to indicate that these lines really are perpendicular, remember you need your right angle mark there. And I guess for good measure, let's call this L, because that was our basic line. We'll call this line P for, well, perpendicular, and we'll call this R for parallel here. Now if I wanted to list these two lines are parallel, R and L, remember our symbol for parallel. And let's remember our symbol for perpendicular. P is perpendicular to L. Perpendicular is that upside down T. Okay, so only one line you can draw that's perpendicular or parallel to a line from a random point not on that line. We will look at this example in class. I actually have a swing set here, and I want you to take a look because I want you guys to tell me in class, but identify in this picture some perpendicular lines. Can you find some pairs of lines that are perpendicular using items and things in the swing set? Can you identify some parallel lines in the swing set? And can you identify some skew lines in the swing set? Again, skew cannot be on the same plane, but they also cannot cross. So we'll talk about that in class. And now moving on to something really critical that you're going to see for the entire year here. When a transversal hits two other lines, we have very important angle pairs, and we need to know the names of these angle pairs. Now, first things first, what is a transversal? A transversal is any line that intersects or crosses two or more coplanar lines, creating pairs of angles. So a line that crosses two or more lines in the same plane, right? Coplanar. Now if you take a look, there are three lines in this picture. Which one is a transversal? Which line actually intersects two or more others? This here is my transversal, so I'll draw a little arrow here. My transversal is this line here, we'll call it T, because it crosses 1, 2 lines. And I just put angle numbers here to identify what angles I'm talking about. We're going to have 4 types of angles that we're looking at. We're going to have corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles, also called same side interior angles. And these are all pairs of angles. It's all angles that fit this description. Now corresponding angles, we'll talk more in class, but it's kind of like if you made the shape of the angle with your hand and slid it down, you would make that angle again. Pretend, or do this actually, put your hand up to the screen and make angle 1 so that your thumb would be right here. Take your right hand, put your thumb here, and your fingers so that they line up with this line here with the transversal. So you're making angle 1, and now you're going to slide your hand down until you hit, oh, angle 5. Look, thumb going out this way, fingers going out this way, thumb going out this way, fingers going out this way. So 1 and 5 are corresponding angles because they are corresponding. The shape that you would make with your hand on those angles is the same. To make angle 2, you would put your left hand up and put your left thumb here and your fingers out this way. You slide your hand down the transversal and suddenly you're going to make angle 6. Your thumb is going to be there, your fingers here. So angle 2 and angle 6 are corresponding because they're sort of in the same shape, I guess. You'd make them the same way. They're on the right of the transversal. They're above both of those lines the transversal crosses. Corresponding places in that picture. And let's say you were going to make angle 3. You'd probably take your right hand, put your thumb this way, and extend your fingers out that way, kind of turning your hand. And you'd slide your hand down, and you'd come to angle 7. So angle 3 and angle 7 are corresponding angles. And we have one more pair of corresponding angles. If I'd make angle 4 with my left hand, thumb here, fingers out here, slide your hand down the transversal, you'd make angle 8. Corresponding angles in the same type of position off of that transversal. Notice I have 4 pairs of corresponding angles. And we're going to talk about alternate interior angles. First of all, interior, you know, means inside. Now, if I was talking about inside angles, I'm talking about the angles in between the two lines that the transversal crosses. So I'm looking for all the angles in the interior, in the inside, which includes angles 3, 4, 5, and 6. But I want alternate interior angles, and alternate, you know, kind of means opposite. In this case, it means as far from each other as you can get. So angle 3 was an interior angle. I want the alternate one from that. What angle is the furthest away from angle 3? Angle 6 would be the other interior angle, as far away as I can get. Those are a pair of alternate interiors. The cool thing about alternate interior angles is you actually make a Z shape when you make the angle. If you make angle 3, there it is, and if you make angle 6 and you go on those rays, hey look, there's angle 6. Okay, so you make this Z shape, and those are alternate interior angles. There's one more pair of alternate interior angles. Angle 4 was an interior angle because it was in between these two lines. Well, I want the alternate one as far away from angle 4 as I can get, and that would be angle 5. Again, you see that Z shape. If I make angle 5 and I make angle 4, I'm doing really bad right now, but you get that Z shape again. Another type here, alternate exterior angles. Exterior, you know, means outside angles, and the outside angles would be 1, 2, 7, and 8. But to be alternate, you want to be as far away from each other as you can be. So angle 1, which other exterior angle is the furthest away or totally opposite from angle 1 on the other side of the transversal all the way to the other side, and we'd go to angle 8. There's another pair of alternate exteriors because angle 2 is an exterior. And where would its alternate exterior be as far away as from angle 2 to the other side of transversal all the way to the other side here? Would be angle 7 is its alternate exterior angle pair. And the last thing we're looking at here, consecutive or same side interior angles. Consecutive means one after another, but they have to be on the same side in the interior. Oh my goodness, so consecutive interior angles. Now remember how these 4 are interior angles? 3, 4, 5, and 6. But I want to be on the same side of the transversal. So if I would pick angle 3 and I want to pick the other angle that's on the same side of the transversal, here's the transversal, which interior, right, is on the same side of the transversal? Well, angle 3 and angle 5 would be consecutive interiors. And then I look at the transversal, I go to the other side, which would be over here, and I want the 2 interiors on that same side, which would be angle 4 and angle 6. So looking at different types of angles off of a transversal, remember our transversal was this line because it hits 2 others. Corresponding angles make the same shape, like angle 1 and angle 5. You notice if you made that with your hand, it would be the same kind of formation, you just slide down. They're both above these lines and to the left of the transversal. You could look at angle 2 and angle 6 being corresponding, because if you make angle 2, there's the shape. Angle 6, same idea. You're to the right of the transversal, you're above these lines. They correspond, they're in the same type of position. And our other corresponding, of course, was 3 and 7, both below these lines, left of transversal. 4 and 8, both below the lines, right of transversal. Alternate interiors, opposite, totally opposite in the inside, 3 and 6, 4 and 5. Alternate exteriors, totally opposite on the outside, 2 and 7, 1 and 8. And finally, consecutive interiors have to be the same side of the transversal on the inside, so 3 and 5, and 4 and 6. In class, I want you guys to help me out. We're doing a new example, and if you notice, the picture's a little bit different. We still have a transversal. This would be my transversal because it hits 2 others. I numbered differently, and you guys are going to help me out identifying corresponding angles, alternate interiors, alternate exteriors, and consecutive interiors. This is your homework off of the notes for tomorrow, so bring this in completed.